Welcome to The Explainer. Today, we're diving straight into the real operational reality of enterprise AI, specifically looking at the NVIDIA AI factory control plane architecture. If you've been following the AI space even a little bit, you already know it's moving at lightning speed. But actually running these massive systems inside a large business, well, that's a whole lot more complicated than just plugging in some shiny new hardware. Let's get right into it. You see, enterprise AI conversations almost always start with GPUs. And honestly, that makes perfect sense, right? They're the visible engine. They're the highly coveted, scarce resource that literally everyone is fighting over right now. But here's the hard truth. Production AI does not succeed simply because an organization bought some accelerators. Buying those incredibly expensive GPUs, that is literally just the starting line. It is absolutely not the finish line. Okay, let's really dive into this. What we're talking about isn't just a basic server room anymore. It's what NVIDIA aptly calls the AI factory. This is the massive operational arc we need to wrap our heads around today. We really have to shift our mindset. We have to move away from just thinking about owning hardware to actively operating a complex, breathing system. A factory that actually turns raw enterprise data into real, actionable intelligence. So, here's our roadmap for this explainer. First, we'll tackle the great GPU misconception. Then, we'll enter the AI factory. From there, we'll look at orchestrating the hardware engine, followed by standardizing inference and agents. After that, we'll check out blueprints for production AI, and finally, wrap it up with designing your control plane. Don't worry, we're going to break this whole stack down piece by piece. All right, kicking things off with Section 1, the great GPU misconception. Let's unpack this. The fundamental mistake so many organizations make is starting with the hardware and just kind of assuming the rest of the software architecture will magically fall into place. It won't. A truly effective AI control plane has to manage a massive, massive scope. We're talking about GPU capacity because, again, they are scarce and have to be shared. We're talking workload orchestration to handle wildly different performance profiles. You need repeatable model deployment and, of course, absolutely strict governance and risk policies. If you aren't controlling how data, users, and workloads actually flow through your platform, well, those GPUs are essentially just sitting there, generating a lot of heat, but zero business value. Moving right along to Section 2, enter the AI factory. Let's see how we actually solve this control problem. Take a look at NVIDIA's full stack architecture. Notice how beautifully layered it is. You don't just have physical hardware sitting at the bottom, you actually have distinct software platforms floating above it, with each one designed to control a very specific part of the AI lifecycle. Because, like we just established, there is no single, magical, monolithic tool that solves everything. To make this work, you absolutely need a coordinated, layered architecture. And at the very foundation of those software layers is NVIDIA AI Enterprise. Now, why is this so critical? Well, because enterprises don't just need cool experimental innovations. They desperately need supportability. Without a standardized, validated foundation, development teams usually end up using a totally disconnected hodgepodge of tools. One team uses this framework, another uses that container. And honestly, that is exactly how AI pilots become incredibly fragile. They just break the second they hit real-world production. NVIDIA AI Enterprise provides that packaged software layer, the essential security updates and repeatable deployment patterns that takes an organization from doing fragile experimental AI to running robust operational AI. So let's shift our focus up the stack for Section 3, orchestrating the hardware engine. Okay, so once those precious GPUs are finally physically inside your building, the immediate headache is allocation. This is exactly where NVIDIA Run comes into play. It solves a massive, incredibly common issue known as GPU fragmentation. Think about it. You might have millions of dollars tied up in accelerated compute, but if it's statically assigned to specific users, one team might have hardware just sitting idle, while another team is stuck waiting in line. Not ideal, right? NVIDIA Run uses dynamic scheduling and smart workload prioritization. It essentially takes raw GPU ownership and converts it into shared, highly efficient enterprise capacity. It ensures your expensive hardware is never just sitting around collecting dust when there's actual work to be done. And this brilliantly illustrates our next layer, NVIDIA Mission Control. While Run handles the actual workloads, Mission Control manages the factory itself. Listen, at enterprise scale, you simply cannot manage AI infrastructure manually. It's impossible. Mission Control bridges this critical gap between AI ops and your actual physical data center facilities. It gives you real-time visibility into physical constraints, things like power draw, cooling limits, and rack-scale architecture. In a high-density AI factory, a simple software scheduling decision can literally alter the thermal profile of your entire data center. Mission Control sits right at that vital intersection between what the software wants to do and what the physical reality can actually handle. Now we're moving on to the actual production lines. Section 4, Standardizing Inference and Agents. Training a new model gets all the flashy headlines, but inference, actually using that model in the real world to generate responses, that is where it actually becomes a viable service. This is where NVIDIA NIM steps in, providing optimized, ready-to-use inference microservices. Because think about it, a model just sitting somewhere in a repository is not a production service. To be useful, you need a live API endpoint, you need predictable scaling behavior, and you need continuous security updates. NIM bridges that massive operational gap. It makes model deployment repeatable and incredibly performant, rather than being a massive one-off engineering headache every single time you launch a project. Now, what's really interesting about this next evolution is the shift from simple chatbots to actual agents. We are watching a fundamental change in enterprise AI right now. We're moving away from a chatbot that just politely answers a question toward an agent that actually takes action. We're moving from simple prompt and response setups to highly complex compound systems. A single user request today might trigger an agent to execute document retrieval, run strict policy checks, trigger external API actions, and manage a multi-step workflow. It's a whole different ballgame. And to handle all that newfound complexity, we have NVIDIA NeMo. These new agents, they need access to tools, memory, and sensitive data. But because of that, they also desperately need strict guardrails. NeMo acts as the essential control layer to build, evaluate, and actually govern these complex agentic systems. It gives operations teams the ability to confidently ask and answer the most critical question: can this AI system act safely, efficiently, and strictly within our corporate policy? Up next is Section 5, Blueprints for Production AI. Let's talk about bypassing the dreaded blank canvas problem. Look, organizations absolutely know they need AI, but starting completely from scratch every time is incredibly slow and frankly super risky. NVIDIA Blueprints provide repeatable patterns for exactly this reason. We're talking about pre-configured workflows for things you actually want to build: retrieval augmented generation, customer service copilots, digital humans, vision analytics, document intelligence. Now, these blueprints don't magically do all the work for you. You're still going to need governance and proper integration, but they dramatically accelerate the path from an ambitious idea to a working, production-ready implementation by giving your team a proven, rock-solid starting point. All right, bringing it all together in Section 6, Designing Your Control Plane. So the crucial point I want to leave you with here is this. You need intentional control plane design, not just a random pile of components. The reality is that almost all enterprises operate in a messy, hybrid world. You might be running VMware, Kubernetes, or various open source frameworks right alongside NVIDIA native tools. And that's okay. The goal here isn't blind standardization on one single vendor for every little thing. The real goal is intentional design. You have to actively sit down and decide which layer controls what, where NVIDIA Run makes the most sense for your GPUs, or exactly where NeMo governs your agents, so that everything integrates smoothly across your on-prem and cloud environments. Please do not design your AI infrastructure as a pile of disconnected components. Design it as an integrated factory. Which leaves us with this final provocative question, one you really need to be asking your own teams right now. How exactly will you control the AI factory once those GPUs arrive? Remember, it is not just about how many shiny accelerators you can buy. It's entirely about whether you have the operational control plane required to turn that expensive hardware into a functioning, governed, and highly efficient intelligence factory. So think critically about your architecture, think deeply about your operations, and make sure you are building a system that can actually scale. Thanks so much for joining me on this explainer, and keep learning.